program. With me also today is Mike Arblaster, who is the Pennsylvania program coordinator. Mike can answer any questions that you have about the program in Pennsylvania and Ohio, really. I mean, we're both pretty informed on both programs, but Mike's the guy for Pennsylvania. I'm the guy for Ohio. Mike Turns is not with us today, but he is our senior program manager. And so if you can't get a hold of Mike or I, Mike Turns would probably be the best person to try. So the webinar series that we're doing this year, we are today on the July 10th episode. So we've got 3 in the tank that you can watch online through the Compass website. If you haven't seen those, I recommend you do that. They're pretty good, we think anyway. Today, again, we're talking about thermal bridging. The next installation will be on September 11th, and that's duct installation and testing. Mike Arblaster is going to do that one. He's going to talk about tight ducts in tight houses, which is a very important topic right now. So, you know, there have been some changes recently in Energy Star that he'll cover, and that'll be a good one. So I'm looking forward to that one. And then we're going to wrap it up in November with water-managed roofs and walls. So just a quick overview of what we're going to talk about today. First thing, how does heat move? Which is a little bit of a review from the air barrier webinar. If you haven't seen that one, we're going to go over that just a little bit just to touch on it. Then we'll talk about what is thermal bridging, where does it occur commonly in a home, why is it important to slow this down, why is thermal bridging a bad thing, and what is required by the checklist. We're going to go over the checklist and each item in the thermal bridging section. And then we'll go over briefly how to sell these things. You know, we're going to put some extra effort into this home. How do we convey the benefits of what we have done to potential buyers? So we'll talk about that a little bit toward the end. So starting off with, how does heat move? Again, this is just a quick review. As we know, heat flows from hot to cold via 3 methods. Conduction, convection, and radiation. To expand on that a little bit, convection is heat movement in a fluid, which is a liquid or a gas at a non-uniform temperature, owing to the variation of its density and the action of gravity. So that's kind of what we talked about in the air barrier webinar. There was a lot of convection. You're heating up a fluid, you're paying to heat up a fluid such as air, and then that fluid is moving from one place to another and taking all that heat with it. Today, we're going to be focusing more on conduction. Which is transmission through or by means of a conductor. Or, you know, there are degrees of conduction. Some things are more insulating, some things are more conducting. But, you know, where are general building materials on that continuum, and why should we, you know, note that that is the case and address it? Radiation, then, the final one is the process of emitting radiant energy in the form of waves or particles. That is what our gentleman here reading his paper is experiencing. As the heat from his stove is radiating out to him via waves and warming him nicely. You know, our teapot here is experiencing conduction. That's one of the ones we're going to talk about, where the pot is in contact with the top of the wood stove, and that heat is being transferred directly through those metals to the water. Again, everything's in contact, which is important for conduction. It's an important thing to note that helps conduction. Conduction moves best when everything's in contact with one another. What is thermal bridging? So I like this quote at the bottom here from Don Henley of Eagles fame. For those of you who don't know who Don Henley is. Sometimes you get the best light from a burning bridge. So this quote sort of reminds us that, you know, bridges are not always a good thing, especially when you're talking about a thermal bridge. So sometimes we want to burn that bridge or get rid of it. What is thermal bridging? This is a nice little quote from an article in the Green Building Advisor. So if you don't know what the Green Building Advisor is, shame on you. It is a nice little blog that Martin Holliday puts out every once in a while. And there's really good information. There's a good archive of stuff there. Good for just perusing if you're alone on a Saturday afternoon and have nothing to do. I recommend the Green Building Advisor. Anyway, thermal bridging occurs when a more conductive or poorly insulating material allows an easy pathway for heat flow across the thermal barrier. The only change I would make is, it's an easier pathway, but, I'm not going to argue with Mr. Holliday. So moving on, where does it occur commonly? So what are some of the places in a home where we see thermal bridging? The big one, of course, is wall studs. You can see down in this picture on the bottom left, all these little vertical lines are studs, and the spaces in between is where the insulation is. So you can see that there is definitely a different thermal performance between where the insulation is, in spaces, and where the studs are, those vertical lines. So there's something happening there where heat is either escaping or infiltrating the home via those studs, because wood is not as good of an insulator as insulation. No surprise to most people. Again, sills and headers for the same reason. At the top and bottom of windows, you've got wood there. Wood is not a very good insulator, and so you've got a place there where thermal bridging can occur. Rim joists, this nice band in the middle here between the first and second floor is the rim joist. And again, you've got the same situation where you've got wood because you need it structurally to hold the building up. We can't just hold it up with fiberglass insulation. That would not be a very structurally sound house. It would be, it would protect against thermal bridging if we could figure out how to do that. So anyway, that's another place. Trusses and rafters, this picture in the bottom right shows sort of a poor man's IR camera, which is the kind I have. And, what you're seeing there is this is probably a cathedral ceiling. They've got an occupiable space, and they've insulated between the rafters. And yet you can see where the snow or frost, that's probably frost, has melted at each one of those rafters because the heat is flowing through those rafters at a greater rate than it's flowing through that space between. So you still have the frost sort of in the in-between spaces, but it's melted in all those nice little lines, and you can tell that, there's some heat loss happening there through thermal bridging. Windows and door frames, again, in the bottom left there, the same situation you have. You've got wood instead of insulation. That's a place where things can travel. Or, maybe your door or window is a different material like aluminum, heaven forbid, without a thermal break in it. And then you're getting really good transference of heat through that material. Next one is basement walls. In this picture, sort of on the right-hand side there on the top, you can see a basement wall, call it, poured concrete or concrete block, where they have draped some fiberglass insulation on the inside, maybe 3 or 4 feet down, and then on the outside there's the rigid board up against the foundation wall. But neither of them goes the entire height of the wall. They're sort of relying on the combination of the two to stop heat. But as we know, concrete is a very poor insulator, and you will, in this situation, get heat loss through that concrete. It'll wind its way around, from the outside. If it's hotter outside and cooler inside, and you're trying to cool the inside, the heat will find its way through that concrete down and into the building that way. Conversely, in the wintertime, when you've got a warmer basement, cold outside, heat's going to find its way, through that part that's uninsulated, that bottom portion of the wall, up the concrete, which is a better conductor than it is an insulator, and out where that top part is exposed to the outside air. So, this is a situation where it's sort of a roundabout way, but there's definitely heat loss through thermal bridging happening there. To fix that, we really ought to finish off one of these or both of these insulation situations here. Either on the inside here, take that all the way to the bottom, or on the outside, which is the better option, on the outside, take that rigid all the way up to the top. Veneer ties, I don't have a picture of that, but up here on the wall section where we just talked about, if you can picture this as a brick veneer, and then very often you'll have these nice metal ties that hold the brick veneer to the wall, and they attach right to the stud. Well, that's a nice place. Metal's a really good conductor. That's a nice place for heat to escape, through the stud and then through that nice metal tie to the brick and then outside. So that's another place where you can get a lot of thermal bridging. And then finally, cantilevers, this picture in the center on the bottom is more of a multifamily / commercial application, but it's a very common thing that you'll see. where they just take the structure and extend it out a couple of feet and call that a balcony. But what happens, a lot of times that's a concrete slab. Again, concrete's a great port insulator, so you get all that heat that you're trying to conserve in the wintertime is just following that concrete right out, and basically it's a radiant heater for anyone sitting on the balcony below. So a lot of thermal bridging happening there. So that's another place where you can run into it quite a bit. And that's also something that can happen in homes, if you think about if that deck, that balcony above is maybe just a second floor that protrudes a foot or two, then, a lot of times what we'll do is structurally just extend those second floor joists out a couple of feet, and that's how we support that cantilever. But again, that's an opportunity for thermal bridging to occur. So we need to address that. What is required by the Energy Star checklist? I like this quote on the bottom again. This is from Atul Gawande from the Checklist Manifesto. And basically, I'm not going to read the whole thing. You guys are all perfectly capable of reading. But basically what he's saying here is that, even the most experienced of us, people who do this stuff every day, can benefit from a good checklist. Checklists are a practical way to make sure that you've done everything correctly and in the correct order. And it's a quick way. You don't have to put a lot of thought. You don't have to use space in your brain to memorize all of these things. If it's on a checklist, you can look at it, go down through, make sure that you've done all these things, and use your brain for other things. It's kind of one of the points that he makes in his book. So moving on, what is required by the Energy Star checklist as far as thermal bridging goes? This is the thermal bridging section, section 4 of the thermal enclosure system radar checklist. It's not a very big section, but it's an important one, and it's one that gives some voters a little bit of heartache with the requirements that are here. So we thought it was a good idea to spend some time and go through it. We're going to go through each of these items in depth. The only one on here that we're not going to hit in depth with its own slide is the one marked here at 4.3, because it's pretty self-explanatory. Insulation beneath attic platforms. So if you've got an HVAC platform or some kind of walkway in your attic, you need to have R21 basically underneath that. So you can't just, because they recognize that if you've got a pathway up there, you've got some kind of walkway, you can't just go and pile on more insulation, but they want to make sure that there is a minimum there at least for thermal bridging purposes, and that's R21 in our climate zone. If you happen to be in climate zone 6, it's R30. So some of those areas in Pennsylvania where you're in climate zone 6 recognize that that's a little bit different for you guys. So moving on and hitting them each individually. For insulated ceilings with an attic space above, i.e. a non-cathedralized ceiling, so you've just got a flat ceiling, it's a truss, something like that. What you need to have is R21. Again, this is for climate zone 5. You need to have an R21 at the inside face of the exterior wall. So right here where this red line is, you need to have at least R21. So whatever kind of insulation you're using, I'm not going to give you a number and say you need 9 inches, 6 inches, 5 inches. It's whatever the R value of your insulation is that you're using. Make sure that you get to R21 at that point. So if you have to use a raised steel truss, if you have to, do some other type of insulation just at the edge, whatever you need to do to get there, Energy Star says R21 is what we want there. Here's a big one for 4.2 for slabs on grade in climate zone 4 or higher. 100% of the slab edge is insulated to greater than or equal to R5 at a depth specified by the 2009 IECC and aligned with thermal boundary of the outside walls. And then there's a couple of footnotes that are kind of important on this one. So we're talking about slabs on grade, which for our purposes is defined as anything less than 12 inches below grade. That that's where the slab is. If you're more than 12 inches below grade, then you're, I guess, a basement or a crawl space or something like that. slab on grade, we're talking about 12 inches or less below grade. But this note 4 is talking about, again, that 12-inch requirement, and that the insulation needs to go to the top of the slab to provide that thermal break. If it's between the exterior wall and the edge of the interior slab, it shall be permitted to be cut at a 45-degree angle. We'll get to a picture of that. That's kind of hard to picture sometimes, but there's a photo of that in some of the upcoming slides. Or you can just use R3 rigid on the top of the existing slab. Again, if you're doing a gut rehab, what you can do is just lay down R3 on top of that, and you can leave 10% of the slab surface, not insulated if you're doing that. So if you need to have sleepers on there, sill plates, that kind of thing on the slab, and you're doing an existing slab, you can take that existing slab, lay R3 on it, and that would be considered, okay as far as Energy Star is concerned. So that's something, again, to keep in mind, especially if you're doing full gut rehab. And then the other thing, this note 5 talks about the insulated wall between a garage and the rest of the slab. So you need to make sure that there's a break there because, in general, we're trying not to condition garage air. We don't want to, we don't want anything that's going to force air into that space and thereby maybe force air into the home, right? So that slab is generally going to be a lot colder than the slab of the rest of the home. So we want to make sure that we get some kind of a break between that garage slab and the rest of the home. And there's more information if you follow this link, but that's the general gist of number 5. So a little bit easier to see in the pictures here. So for concrete build 4 and higher, we need to insulate the slab edge at the depth, per code. What you see on the left hand with the red frowny face is a way not to do this because, again, this slab insulation looks good from where the slab is going to be down, but once they pour that slab in this little bracket, this L-shaped part on the on the right-hand side of that, there's going to be pretty much direct contact between the foundation wall, which is exposed to the exterior, and the slab. So there's going to be a lot of bridging happening right there at the edge of that slab. Conversely, if you look at the picture on the right there, you'll see a nice layer, complete layer of insulation between where the slab will be poured and that exterior wall. You've got 1 inch vertically, looks like maybe 2 inches horizontally, and there you're going to get a nice thermal break between the slab and that part of the foundation wall that is exposed to the exterior. Same situations here on the bottom, but this one talks more about the 45-degree angle. So, again, on the left, when that slab is poured, hopefully they're going to fill that with a little bit more aggregate. But when that slab is poured, you're going to get, again, direct contact with the outside wall and the slab, so that's not good. On the right, this is acceptable. You've got the insulation is here, but it's cut on a 45-degree angle. And why would you want to do that? Well, some contractors want, maybe this is going to be carpeted and they need to take it all the way out to the edge, or maybe it's going to be stained and they want that nice visual continuation of the slab. They don't want to see that edge there. In those cases, what you can do is cut that slab or cut that insulation at 45 degrees. It's acceptable for Energy Star, I'll say that. You may not want to do that for other reasons, most of them being the fact that you're tapering that concrete out to basically nothing here at the edge, and it's just not going to be very structurally sound, I'm sorry, as far as concrete goes. Concrete that is basically tapering down to nothing is not going to last very long. It's going to chip away and other things like that. You're going to have issues with it later on. But as far as Energy Star is concerned, it works for thermal bridging, so that's all we're worried about today. Um, 4.4 thermal bridging at above grade walls. This is one of the big ones that contractors struggle with. So there are a couple of ways to deal with this one. First of all, 4.41, you notice that, they do say in 4.4, you need to use one of the following options. There's a bunch of options. We're going to get to each one of those individually. The first option is you can wrap the whole thing in R5, right? You can take basically 1-inch foam, put it on the outside of your building, and you're good. You've got a good thermal break. It's going to perform well, as far as thermal bridging, it's going to perform well as far as just insulation goes. And it's, it just by the virtue of being what it is, it's well sealed with tape and all that kind of good stuff, you're also going to perform pretty darn well as far as air infiltration goes with this system. So it's a good system. Of course, it's also an expensive system. So, each builder is going to have to weigh the pros and cons of this and decide. So again, this is probably the best way to do it, but there are other ways that Energy Star says you can do it. One of those, of course, is by using one of these alternative methods of construction. Right now, honestly, I'm in the middle of a vacation. I'm in the forest of Bradford, Pennsylvania, and I can't help but think of s'mores when I look at this left-hand picture. Just add a layer of chocolate in there, and you got graham crackers and marshmallow, and that's just what it reminds me of. Sorry, that's just the mind frame that I'm in. But anyway, those are sips, obviously. Those what they really are. That marshmallow is actually foam insulation, and the graham crackers there are OSB. So that is certainly a way to help thermal bridging. If you don't have the two parts touching, you've got insulation in the middle. You've got a good system as far as thermal bridging goes. So structural insulated panels are certainly one way to deal with thermal bridging that Energy Star says is completely acceptable. In the center picture, you've got insulated concrete forms, or ICFs. Another great way to deal with thermal bridging. Instead of the insulation being sort of sandwiched between two structural members, here you've got the opposite. You've got the structural stuff being sandwiched by two layers of insulation. So you've got insulation, then they're going to pour concrete here inside, and then you've got more insulation on the interior, and you've got an insulated concrete form. Again, another very tight, very good way of building as far as thermal bridging is concerned. Not the cheapest way to do it. So again, all of these things have pros and cons. On the far right here, what you've got is a double wall construction, double wall framing. So you've got basically a 2x4 wall, then a space that will be filled with insulation, and then another 2x4 wall. These two 2x4 walls are only joined by, in this case, it looks like a piece of OSB, where they've joined the two, tied them together in that way, and so that's the only place that is a possibility of a bridge between the exterior and the interior. It's one very thin piece of half-inch OSB or whatever it is, so not much of a bridge at all, and it's long, and so that's a good way to deal with thermal bridging. Again, obviously not the cheapest way to do it. So what is the cheapest way to do it? Well, this would be my vote. As far as the ways that Energy Star spells out for meeting thermal bridging, this is going to be the most cost-effective. What you can do is advanced framing, and many of you may have heard of advanced framing and have sat through webinars and explanations of what it is. But please note that in those other venues, you may have heard of a lot of other different ways to do advanced framing. There's a lot of stuff that constitutes what I would call advanced framing. But Energy Star, frankly, just doesn't ask you to do. They call for exactly these 5 things. If you want to do more aspects of thermal bridging, that's great, but you don't have to. As far as Energy Star goes, all you have to do as far as advanced framing is 4.4.5a, all corners insulated to greater than or equal to an R6 to the edge. So what that means is you've got to do something at the corners where you don't have basically a box, an uninsulated box at the corner, which is what I would call conventional construction. And we'll get into each of these again individually coming out, but I just wanted to present them individually, here as a group so you can see everything at once. Point 5B, all headers above windows and doors insulated to R3 for 2x4 framing or equivalent cavity width. So if you've got 3.5 inches of cavity, you need an R3. R5 for any other assembly. So if you do 2x6 or something else, you need an R5. You need framing at your windows and doors limited to 1 pair of kings and 1 pair of jacks, unless more is required structurally. If you need more bearing for that header, basically all you need to do is, have the architect, engineer, designer say so that, this header needs 6 inches of bearing, and that should be enough to convince the rater the need for a couple of more jack studs there, for example. And just common sense, if it's a 3-foot opening, you really only need 1 pair of jacks, 1 pair of kings. If it's a 10-foot opening, obviously you're going to need more. Point 5C, sorry, that's the one I just talked about. Point 5D, interior and exterior wall intersections insulated to the same R value as the rest of the exterior wall. That is basically when you have that interior wall coming in to hit the exterior wall, you got to make sure that that is insulated the same way. You don't have that 3-stud box like you typically see. And we'll get into pictures of this stuff in a minute. And then minimum stud spacing is basically 16 inches on center now. When it first came out, they wanted 24-inch centers. They backed off a little bit, and you can even do 16 inches in a 2x6 wall now. You could do 16 inches in 2x4 in all climate zones, and in 5-8 they wanted 24 inches on center for 2x6 framing. But you can still get away with 16 again if you go to that R20 in the cavity, which a lot of people have been able to hit. So just another couple of things that I wanted to point out here. If you do these things, that's going to, in most cases, that's going to cost you less than the sort of standard framing that we do in terms of it's going to be less wood. If you don't have the framers just slapping up 2x4s wherever they think it's needed instead of really thinking about it. It's going to be less labor, not only for the framers but also for the electricians and plumbers who have to drill holes through all those studs a lot of times. If there's no stud there, then they don't have to drill a hole through it. And so that quickens their time on the job as well. So very quickly to get through these individually, 4.4.5a, here's what we're talking about. Either do something with, you have a 2-stud corner here. This is an exterior wall, Either do something with some kind of a drywall clip, or you can turn a piece of 1x, or even just take that 2x4 that you were normally you would put sort of right there and have, again, that box. Even just turn that. As long as you can get to R6 behind that, then you're good. So we want, again, that insulation going all the way out as far as it can into that corner. Insulated headers. Again, we're going to want at least R3 for a 2x4 and R5 for anything else. They don't specify where you have to put it. You can put it on the outside part of the header. You can sandwich it between two pieces of wood for the header, or you can put it on the inside. However you do it, you just have to get to at least R3 for 2x4, R5 for other assembly. So get as much insulation in there as you can, basically, but at least R3. So when we're talking about jack studs and king studs, just in case you don't know what I'm talking about, these are jack studs that go up to the bottom of the header, and the header sort of sits on them. That's jack. King goes all the way up to the sill plate in the header, from the sill plate to the header, I guess. So that it goes the full height of the wall. And this is all you need for most openings. 1 pair of jacks, 1 pair of kings, attach your header. You can even use hangers if you wanted to, but this is perfectly acceptable. And again, underneath a window, really, if you don't need a whole bunch of what we call cripples down there, just because we don't support windows from the bottom, right? We hang them. They're hanging from the frame. They're attached all the way around, generally, via some sort of nailer. So these cripples are not structural. They're literally just to nail and screw drywall to. So that's all you need, just to maintain your spacing, to keep your 16 inches on center from your wall. That's all the cripples that you need down there. So again, if these openings are bigger, you may need more for bearing. But in general, most of the openings that we see in a home are only going to need one set of jacks, one set of kings. This is where we have that exterior wall meeting an interior wall situation. Again, you can use clips. You can take a 1x6 and just turn it sideways, and there's your nailer on both sides. Or what a lot of people do is just ladder blocking. Just pop these in there like a ladder all the way up. That enables you to get that insulation in behind them for a nice, well-insulated exterior wall all the way up. So again, we're trying to avoid that box of studs where we can't insulate. And then 4.4.5E, minimum stud spacing of 16 inches. So we're looking at 16-inch on center, keeping that even across openings, and that's all you need. Especially if you get to that R20 value, even in 2x6s, you can get to 16 inches. So let's get to the fun part: selling the benefits of the home with reduced thermal bridging. What we have on the bottom there is the goal of every house that you build, I'm sure, is to sell it. So let's talk about some of the ways we can talk about thermal bridging so that people will understand what we're talking about. First of all, who cares about Energy Star? Just as sort of as an in general thing, not necessarily dealing with thermal bridging, but just dealing with Energy Star in general, who the heck cares, right? So this is from a study called, literally, What Home Buyers Really Want. Came out in 2012. If you've talked to me about this kind of stuff, you've heard me say it before, I'm sure. But here's a graphic of it. You can see that Energy Star rated appliances is number 1 on the list. Energy Star rated windows down there as well. 89% of people either said they must have it or that it's desirable. And the big one is the Energy Star rating for the entire home came in third, with 91% of their respondents nationwide saying that they either would not buy a home without it, which is 28% of people, which I think is also very significant, or find it desirable. They would choose that home over another one, all other things being equal. 91% of people. So I think you can see, and even if you look into the list a little bit further, you look at things like, exhaust fan in the bathroom. What's that about? Well, that's probably, either they're getting condensation on their windows in their existing home, or they don't want their mirror fogging up, or they've had issues with mold and moisture in their bathroom or something like that. So they recognize that having that fan in the bathroom is something that helps the home perform well. Ceiling fans. Why do people want ceiling fans? It's a nice way to cool off in the summertime. Again, it's a comfort thing for the most part. So if you look at this list, this top 10 list of things that home buyers really want, fully half of them deal either directly with Energy Star by having Energy Star in the name, or they have something to do with a comfortable, longer-lasting, more durable home. And that's exactly what Energy Star delivers. So if you can make that case, you're hitting a lot of the points that people want in their new home. So just some general building science sales tips. You've got to know your audience. You've got to ask questions about their existing home if they've got one, or their existing apartment, or whatever their existing space is. What do they like about it? What don't they like about it? And that'll help you gauge, those answers that you're pulling out are going to help you gauge their understanding of building science. Are they people who are very technical oriented, or do they just want to be comfortable? Do they just want to use every home in their house to its fullest ability and not have that second floor bedroom that's too hot to use in the summertime, that sort of thing. And so if in case you run into one of those people who's very technically oriented, that's been on the internet, that's studying this stuff, understanding the building science behind it is going to help you explain, maybe help answer some of their questions that they uncovered during their research, or just even to just explain why the home that you're going to build them is going to be better and meet their needs better and be more comfortable than either their existing home or, the guy's home down the street that they're also looking at. And again, the people who need to know the most about building science are the people who are going to have the direct interaction with the customer. So the sales staff really needs to be the most well-trained building scientists on your payroll, even more than the people who are putting it together, because you can tell them what to do, and hopefully they'll do it and they'll do it correctly. It's certainly a good thing to have them understand the building science behind it. But if the person selling it can't convey those benefits to someone who doesn't deal with this stuff every day, then you're going to have an issue. You need that sales staff to really be on the ball when it comes to the building science behind all this stuff. Now, there's also a danger of that when that person is, the most well-trained building scientist on your payroll. We tend to want to put all that knowledge out there and tell everybody everything we know about this stuff. But you don't want to get too technical with customers that don't want to hear it. It's, you do want to communicate your expertise, but you want to do it in a way that speaks to what they want and what they need in a home. Don't hit them over the head with all of this technical information that they really don't understand if they're not that type of buyer. A great way to do that is to use props. Wall mock-ups. I really encourage everybody to do wall mock-ups. It's a great way to be able to see, to touch the things that are behind the walls that you can't see just from a walkthrough in a model home. If you have an area or even just a little tiny mock-up or two, I would recommend two. So a sort of standard construction one. This is what most other guys are doing versus here's what we have done, and then you can compare and contrast those two different mock-ups. And the thing about having these mock-ups and props and all those things are that you're involving more of their senses. The more senses you involve in the sales process, the more likely people are to remember what you're trying to tell them. And there was actually a Harvard study done on that the more senses you can get involved in anything, the more likely people are to recall it at a later date. Smells of grandma's apple pie bring back certain memories, all that kind of stuff. So see it, hear about it, touch it, smell it, or don't smell it. If you walk into a home and the first thing you say to somebody is, "What do you smell?" And their answer is nothing, and it's in your home, that's a good thing, because that sort of quote-unquote new home smell is similar to a new car smell. What that is VOC, volatile organic compound. It's basically toxin. So if you walk into a new home and you don't smell anything, that is something that you want to make sure that they notice, that it's just fresh air that they're breathing in this home. So see it, hear about it, touch it, smell it. But, don't taste it. We don't want people out there tasting building materials. That's probably not one of the senses we want to involve in the sales process. So anyway, it's a good, I put that link in there, ways to keep your memory sharp at any age. It's got a bunch of different tips on memory, just memory in and of itself. So if you want people to remember your sales pitch, do some of these things that Harvard recommends. Anyway, so the benefits of decreased thermal bridging, what we're talking about today. Again, no discussion is no benefit, and it leads to only an increased cost and no increased value to your buyer. So if you don't talk about it, you don't convey why it meets your buyer's needs, then all it is an increase in the sales price, right? It's like those builders out there that say, sure, I can give you an Energy Star home. It'll cost you $5,000 more, and that's the end of the discussion. If you're not conveying the benefits of why an Energy Star home is going to better meet your needs, then that might as well be the conversation you have. And obviously, those people do not choose to do Energy Star, right, unless they do it with somebody else who has explained those benefits. So specifically what we're talking about today, in terms of greater comfort that is caused by decreases in thermal bridging, one of the questions that you could maybe ask, one way to put it, have you ever been in have you ever been cold in a room, even though the thermostat reads what should be a comfortable temperature? You're in a room, you look at the thermostat, it reads 72 degrees, 74 degrees, or whatever, and yet you're chilly. Why is that? Well, one reason that could be behind that is that cold surfaces surrounding the human body literally suck the heat out of your body. So heat always wants to transfer. This is back to our 3 modes of energy transfer. And what we're talking about here is radiation. Anything that's a warmer body is going to radiate out to a colder body. So if the walls of the room are cold, and you're this nice warm human being at 98.6-ish degrees, your body is going to radiate heat out to that colder surface. But if we can decrease the thermal bridging that's happening there, basically increase the temperature of that wall, the inside temperature of that wall, the exterior walls themselves are warmer, not just the air inside the home that we're paying to heat. You know, we have the furnace heating and blowing out into the space. So if we can actually warm those surfaces, you're going to be more comfortable. You're not going to experience that being cold in a room where you should be comfortable. So then the way, you know, if you say, you know, the cold surfaces literally suck the heat out of your body, which is kind of true, you can end that conversation by saying, if you wish, you know, our walls don't suck. They don't suck the heat out of your body. They keep it nice and warm. You stay comfortable. So again, using a little bit of humor always helps with recall as well. My sales tips to you, use them at your own discretion and or peril. Another thing, you know, use analogies. Things like, you know, if you've got that exterior rigid layer on the home, it's like wrapping the house in a nice warm blanket, right? Whereas standard construction is like wrapping the house in a blanket full of holes. So you've got either this nice warm blanket that covers everything, you know, including your feet. They're not sticking out. It covers everything in a nice continuous layer, and you're nice and cozy and snug inside the home, versus, you know, sort of standard construction where you've got these holes, which are the studs where all that heat is escaping. And, you know, obviously that's not as comfortable. So that's one way to put that kind of situation. And, you know, by no means do you have to use that one, but you're free to use it if you wish. This is another thing that's put out by the folks at energy.gov. This is the Power Words Translator. If you haven't seen that, I wouldn't be surprised if you haven't seen it, because right now it's just in the vetting process. They haven't officially released it, but I put a link to it there anyway. And what this is they realized that a lot of the building science terms that we use, like thermal bridging, doesn't mean squat to the average person, to the person who's out there buying a house. What does that really mean? So what they're trying to do is come up with better language to refer to these things. And there's a whole list of them. And they're taking input from people. So if you look over this list and you see something that you have a better term for, submit it. Maybe it gets in there. But as far as thermal bridging goes, here we go. Reduced thermal bridging, they're thinking that the new building science term ought to be thermal buffer construction, right? So it's providing that buffer the buffer of heat transfer, or, you know, some kind of a thermal buffer between the exterior and the interior. And then they sort of break it down by what's important to any one specific buyer. You know, if this is a person who sort of, it's important to them to sort of live a better life, you know, their quality of life is what's most important to them. You can talk about, again, thermal buffer construction or sound barrier construction, which is also a good thing that we haven't talked about yet. You know, any insulation that is a thermal insulation, in general, is also sound insulation. So anything you can do to reduce thermal bridging, by its nature, also reduces the transfer of sound through walls. So if the home is in a particularly noisy place, or the person inside just really likes quiet, which a lot of people do, self-included, then you can talk about sound barrier construction, which is basically the same thing as reduced thermal bridging. All of those things lead to sound barrier construction. So you're in a quieter home when you're in an Energy Star home that is done. If you're talking about someone who likes a building that works better as a system, as a unit, Maybe they have an engineering background or something like that, and ultra efficiency is important to them, or advanced technology, or that kind of stuff. You talk about the energy-saving thermal buffer. It's a little bit more technical sounding, but it gets more to the point of what we're trying to do here. More advanced thermal buffer technology. Again, they're just trying to come up with terms that might relate to people. If you don't like any of these, use your own. But again, if you're talking to a person who just wants a quality home, their old home's falling apart, they don't want to deal with a lot of maintenance. A premium installed thermal buffer sounds pretty jazzy. Sounds like something you might want. So that's one of the things they're thinking of there. So again, think about the terms, think about the language that you're using, try and relate it to what's important to that buyer. It's basically what we're looking at here. Again, if you've got better terms, feel free. This link is going to be up. In fact, can I do this? No, I was going to try and put that in the chat, but I guess I can't do that right now. But anyway, it'll be available in the PDF version of this that goes out, and it should be available in the recording. So feel free to hit that link. So again, certification, as a certified ENERGY STAR home, we're getting certification. Again, I always say this: use the checklist as a sales tool. Even if they don't look through it, I would print the ENERGY STAR checklist out on a nice, thick, heavy paper and hand it to them. And even if that's all they ever do with it, is just hold it in their hand and sort of weigh it, that's going to tell them a lot about what you have done as a builder to build them a quality home. You have done the U.S. Department of Energy's best practices for new home construction, which is really what the ENERGY STAR checklist is, right? That's what the DOE says is, this is what a home should be right now. The technology is there. There's no reason people shouldn't build to this level. We feel that this is where home construction should be right now, right? So, again, they can flip through it, see some of the headers, and, pretty much guarantee that everything that they scan when they read that thing is going to be something they want in their home. Who doesn't want thermal, a home that doesn't have thermal bridging? Once that's properly explained to them, who doesn't want a well-insulated home? Basically, a quality insulated home. That sounds like something I want in my house. But all of those topics in there, even though they may not understand the actual detailed checklist of it, they can see the extent to which you have gone, and that makes an impact. So don't underestimate that. And again, it's not just an energy efficiency thing. It's also talking about durability, comfort, noise reduction. So make sure that those things are brought up as well. Third-party testing and verification is confidence. We can't stress that enough, that when you have a rater come in, verify all these things on the checklist. Again, even the best builder who's been around for a long time, the best HVAC contractor who's been around for a long time, can miss things. They hire new people. They can't always be on the job at all times. This checklist is a way for them to come back and make sure that everything is done correctly. The rater comes in, checks these things. It's not necessarily looking for a mistake that somebody made and out to get them. It's just making sure that everything was done right. And at the end of the day, everybody gets a better reputation for building a well-done quality home. And that's what it's really all about. And again, don't forget about the marketing tools that are available through ENERGY STAR and the FirstEnergy programs. There are all kinds of marketing resources for partners on the ENERGY STAR site. There's a lot of stuff available through our programs. So again, what you need to do to get those, become a partner, which hopefully you already are. Order the marketing brochures, this Better is Better brochure. I don't know how many times I've said this, but I'll say it again. They'll send you 250 of these. No cost, not even postage. All you got to do is ask for them. The link is there. Access your My ENERGY STAR account, and they've got a lot of nice co-brandable stuff. You can put your logo, put your name right on the material. It looks like it was produced by you. They're fantastic. Great thing. They've got a good marketing staff. They've got well-researched stuff. They put in terms that people can relate to. They've done a lot of research on this because they want Energy Star as a brand to succeed, and they've done a good job with it. Energy Star as a brand has succeeded. It's recognized by just about everyone. So, again, if you've got one of those clients who is a little bit more technical, wants to dive into it a little bit more, they also have these sort of two-page, it's one-page front back, of slightly more technical information that dives in a little bit deeper for all of these things. Complete thermal enclosure system. It's going to talk about thermal bridging. There it is. It's going to talk about air sealing, a lot of the things. They've got one that talks about heating and cooling, water management, efficient lighting and appliances, and independent inspections and testing. So all of the aspects of Energy Star. You've got something that digs into it a little bit deeper that's, again, free. You can just print it out, have it laying around, put it in a folder for people. If they want to look at it, great. If not, it's there. Again, so one of the things that I always like to point out, again, we're talking about the 28% of the market out there who won't buy a home unless it's Energy Star certified. So what that means is you had better get the Energy Star mark on your website, because that's where people are starting nowadays. They're looking for homes. First place they look is the internet, for the most part. I mean, there's still people who just get in their car and go for a Sunday drive, but they're getting fewer and further between. The way most people start is on the internet. And if they're looking for that energy, if they're one of those 28%, they're looking for that Energy Star mark. And if you don't have that on your website, guess what? You're not even going to know they exist. They're just going to keep clicking, and you're going to be one of those builders who says, oh, I would do an Energy Star home for someone if they ever asked me to. Well, guess what? If people want an Energy Star home, they're looking for you as a builder to be someone who offers it exclusively, explicitly. It's on your website. That's something you do as a course of business or as an upgrade, at least. And so if they see that, now they're making that phone call, right? If they don't see that, they're just going to keep clicking. And it's easy to do. Again, just go to the website, Energy Star, and download your logo and get it up there. So just real quick, I see we're at 1 o'clock here. I'm just going to buzz through a little bit of the details of the program. Most of you already know these, but if you don't, $400 per unit plus 10 cents per kilowatt hour. That's the incentive structure in Ohio and Pennsylvania. That's every unit. So if you've got a multifamily project, each one of those units can get that incentive. Eligibility, again, it's got to be located in FirstEnergy territory. CFO dates are important. If you're looking in Ohio, it's anything after March 23rd, 2011. If you're looking at MedEd, Penelec, and Penn Power, you're looking at a CFO date, again, certificate of occupancy. That's the date that the building department says, yes, this home can be occupied by humans. You're looking at something after October 28th of 2009. West Penn Power, you're looking at after June 1st of 2013. As far as the program requirements go, the third requirement would be it has to be 15% more efficient than the 2009 IECC or the relevant code when the project was permitted, which for the most part is going to be the 09 IECC. And the big one, Energy Star certification. For the FirstEnergy program, it's got to be Energy Star certified. Just a quick idea, there is more than just Energy Star out there as far as incentives and as far as certifications go. If you do go to the next level of the DOE Challenge Home, first of all, for an Energy Star home, sort of a standard bare bones Energy Star home, you're looking at about a $550, $650 rebate from the FirstEnergy program. If you go the next step to the DOE Challenge Home, you're looking at a HERS score somewhere around the 50s. What we're seeing there is a little bit more, about 775. Again, this all depends on the home, depends on the heating source, is it electric or gas, all that kind of stuff. But in general, you're looking at about 775, $800 for a challenge home. If you go all the way to passive house, then you're getting to the $1,000 or above. I've had homes that are almost $4,000 come through as a rebate come through the program. So again, the incentives with the FirstEnergy program depend on how many kilowatt hours you're saving. Electric homes are going to perform better than gas homes. Ground source heat pump homes perform really well. We get an average of about $2,300 for every ground source heat pump home that comes through. So think about those things when you're designing the home. Some resources: Energy Star, Challenge Home, the PowerWords Translator, Passive House, Building Science Corporation. All of those links are here. Please use them. Please research this stuff as best you can. Again, get that sales staff up to speed, and tune in next week, or next month. Sorry, not next week. May 8th. That sound right? Doesn't sound right. It's November something. So I got the wrong date on here. Oh well. It was whatever that one was at the beginning. But it is going to be at the end. And there's the link to register. And I think that's it. So got any questions? So what's the real date? Let me get the real date. September 11th. How could I forget that? That's the date of our next one. So tune in then. Mike will be talking about ducks. And other than that, have a great day. And again, if you've got any questions, we'll take them. If not, enjoy the rest of your day. Thanks for attending.